We're going to wrap up our mini lecture set today by talking about Mars, the final one of our terrestrial planets. Mars has a diameter that's 1/2 that of the Earth and a mass that's 1/10 that of the Earth. Even though Venus is more closely related in size to the Earth, Mars is perhaps the planet that is most suited for humans if we ever think about trying to settle another planet. Mars has been extensively photographed by the Mariner mission, Viking, Mars Global Surveyor spacecrafts as well. And we know that there are some rovers on the surface of Mars too. So here's a really beautiful image of Mars. And this week for your engagement check, you're learning a little bit more about terraforming, which is the process of converting a planet so that humans could live on it, trying to form it up like Terra, like the Earth, like us. And you also are going to learn a little bit about earlier astronomers in the days before photographic plates, in the days before telescope resolution improved, where when they would observe Mars, they thought they saw little canals on Mars's surface that they just immediately assumed must be evidence of civilization on Mars. So far, we haven't found any of that evidence yet. On a warm day, the temperature on Mars reaches about 50 degrees Fahrenheit. That's the warmest it can ever be on Mars. Winds on Mars sweep dust around and patchy ice crystal clouds form. And the sky is generally clear enough for its surface to be seen from Earth. So we can directly see the surface of Mars, usually with even small Earth-based telescopes. Mars also has white polar caps, in contrast with the reddish color of most of the rest of the planet. What gives Mars this reddish hue? You can also see Mars as looking a little bit red whenever you look up at it, just even with your naked eye at night. The thing that gives Mars this red color is iron oxide in its surface. Iron oxide is the same stuff that makes our blood red. It's the same stuff that makes rust appear red as well. Valles Marineris is the name of a canyon on Mars. It's named after the Mariner mission, which observed Mars. It dwarfs that even of the Grand Canyon in our United States. Valles Marineris is so large that it would span the length of our entire United States. That's how big it is. Valles Marineris is a rift that runs along the equator, and it stretches about 4,000 kilometers long, 100 kilometers wide, and it's 7 kilometers deep. So you could absolutely stack within it our own Grand Canyon. Mars is also home to the largest mountain in our solar system. That mountain is called Olympus Mons, and it is 15 miles tall above Mars's surface. That absolutely is so enormous compared to whatever we have on our own planet. So let's say, for example, Mount Everest. Mount Everest is only 5.5 miles above sea level, and Mauna Kea, which is a mountain in Hawaii, is only 6.3 miles above the ocean bottom. Mauna Kea, well, actually all the Hawaiian islands were formed by volcanic activity. Mars's polar ice caps change in size with Mars's seasons. Mars has a tilt that is similar to that of the Earth's. So when the North Pole is tilted toward the sun, in its orbit around the sun, the North Pole ice caps start to melt a little bit. And when the South Pole is tilted more directly toward the sun, then the South Pole ice caps tend to melt a little bit. The thin atmosphere of Mars creates more severe extremes in Mars's seasons, which leads to the large ice cap size variations during the course of Mars's year between the northern and southern ice caps. The southern ice cap of Mars is actually frozen carbon dioxide. That's dry ice, frozen carbon dioxide, not frozen water, frozen carbon dioxide. And its diameter varies quite a lot. You see here, it varies from almost 6,000 kilometers in wintertime to around 350 kilometers in the summertime when that part of the planet is more directly tilted toward the sun. Mars's North Pole ice cap shrinks to a size of about 1,000 kilometers at its smallest, and it has a surface layer of carbon dioxide ice, but is primarily composed of water ice. And it's layered in separate layers, okay? And these separate layerings of carbon dioxide ice and water ice are indicative of climate cycles on the planet. The water contained in Mars's ice caps is far, 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 far less than that in Earth's ice caps for sure. Mars also has dunes, just like our Earth has dunes. So in the desert, for example, dunes are these giant hills of sand that are formed when wind constantly flows over that sand, and it starts to pile up some of those sand into different hill structures. And then over time, the blowing of that wind causes these sand hills to shift position over time. So here we're actually seeing a view of some of the dune regions on Mars. The Martian poles are bordered by these immense deserts with dunes blown again by the wind on Mars. And we see these kind of beautiful ripple shapes, okay, from above. And I actually know some people who are planetary scientists, and they studied the dunes on Mars by actually going out into the desert on Earth and studying how dunes move in our Earth deserts and compare that to how dunes are moving in images taken of Mars. There's no real evidence for surface liquid water now on Mars, but there is evidence that it was there in the past. Mars, we think, also used to have, rivers and small oceans and lakes as well. And it's the winding nature of these sort of ancient riverbeds from which we can infer that water once flowed on Mars. Here we have an image of a part of Mars's surface where we have these sort of ancient riverbeds, these rivulets here. We've got some mountain regions or some hills, and where maybe it rained and material would run down off of the edge of those mountains and into these rivers. And then over time, that flowing liquid would erode the surface, and it left these deep etches in the surface of Mars. So over time, that water has since evaporated or migrated to the poles and locked up in ice. But we can see the ancient evidence here that at one point, Mars's atmosphere was such that it was warm enough on that planet for there to be liquid water on the surface. Mars does have an atmosphere, but it is incredibly thin. The atmospheric density of Mars is only 1% that of the Earth's. So even if we went to Mars, we wouldn't be able to step out of our spaceship and remove our helmet and be able to breathe. There is not enough of an atmosphere for us to survive just by stepping off the spaceship and taking off our helmets. The spectra of Mars's atmosphere shows that it is mainly carbon dioxide with traces of nitrogen, oxygen, and water as well. So also it doesn't have the necessary constituent components to be similar to the atmosphere of our own Earth. Mars does have clouds and it does have wind, and Mars gets dust storms sometimes too, and we can observe those dust storms from Earth. And the rovers on Mars also experience those dust storms. For example, there was a rover on Mars called Opportunity, and Opportunity is powered by solar panels. And just a couple of years ago, there was a big giant dust storm on Mars, and it came through by where Opportunity was, and the dust from this dust storm covered up Opportunity's solar panels, and it made Opportunity become too cold. It couldn't warm itself up and keep its operations on, and so then Opportunity eventually ended its mission. It couldn't turn itself on back anymore because it was too cold. The lack of atmospheric density and Mars's distance from the sun makes this planet very cold. The noon temperatures at the equator of Mars reach a bit above the freezing point of water, but not by much. And the night temperatures drop to around minus 67 degrees Fahrenheit. So most of the water on Mars is frozen and is locked up either below the surface or in its polar ice caps. And Mars has 2 moons. We already mentioned a little bit about the moons when we were talking about eclipses. These moons are called Phobos and Deimos, and you can see them right here, okay? They are about 20 kilometers across, and you can see that they're kind of potato-y shaped. They're not very spherical. So we think that they're probably captured asteroids that just ventured a little bit too close to Mars and then entered into a stable orbit around Mars. Their small size prevents gravity from pulling them into a spherical shape. So again, that's why they look like potatoes here. Both are cratered. You can see they have some craters on their surfaces here, which imply that they have been subjected to bombardment by smaller objects. Mars is the only planet to be entirely inhabited by robots that we know about. Here are 2 of those robots. One of these is called Spirit and the other is called Opportunity. I don't remember which one is which. And this middle one is called Curiosity. The Curiosity is currently roving around on the surface, and it's still doing a lot of science work for us. The cool thing about Curiosity is that unlike these 2 that are solar paneled, Curiosity is powered by nuclear power, and so it will not have to worry about suffering the same fate as Opportunity did when it got stuck in those dust storms, because it doesn't need the sun's power in order to keep it going. And that concludes the study of our inner 4 terrestrial planets in our solar system. Even though those planets are all terrestrial, they're all rocky, why are they all so different? Well, it all has to do with their size and their distance away from the sun.